So for our first example, we have that a national study found that college students with jobs worked an average of 22 hours per week. Seems like a lot to me. The standard deviation there is 9 hours, where a college student with a job is selected at random, and we want to find the probability that the student works less than 4 hours per week, assuming that the lengths of time spent working are normally distributed with random variable x to represent them. So first, if we want to think about this in terms of standard normal, if you want to use the table that is, we can always convert this into being in terms of z-scores. That we have z equals 4 minus 22 over 9, because we have x equals 4 in this case. Mean mu is 22, and sigma, the standard deviation, is 9, which gives us a z-score of -2. So if you want to talk about our probability, the probability that x is less than 4 here is the exact same as the probability of z being less than -2. Where, to get that, if we want to use a table, we can use a table. If we want to use the calculator, either the normal CDF in terms of 4, 22, and 9, or -2, 0, and 1, will get us to where we need to go. That is, if we want to find the probability that x is less than 4, it's the same as z being less than -2, or 0.0288, rounding to 4 decimal places. Usually around to 4 decimal places for these, sometimes we do 3. But the big thing here to understand is when we're talking about our distributions, when we're talking about our overall behavior here. Hello again from the editing room. So there's an important subtlety to this problem that I didn't really mention as I was doing it on the board that's worth bringing back up here. And when we're talking about these problems, a lot of our approach comes from the idea that we're working in terms of the standard normal, at least implicitly. It's another issue with the way the book thinks about this, but whatever. That since reality is very rarely standard normal, and we're talking about that as a kind of abstraction in terms of distance from the mean, even though it's kind of unreasonable to imagine something being in the distribution and also just about one googol of standard deviations below the mean, it's still kind of theoretically possible. So we include that potential in there when we're talking about finding the probability. Because negative z-scores just mean below. They don't mean negative values necessarily, and sometimes we don't really have negative values we can actually consider, like in this example here. Where I'll say that some of you guys are probably still just getting used to this stuff. You're still just trying to copy down the picture and see the process in the calculator. You're not too worried about the finer points just yet. But some of you, or maybe paying a bit closer attention to this, might look at the example and say, well, wait a minute. These are hours spent at work. Wouldn't the least amount of hours you can spend at work be 0? And technically speaking, yeah, you're right. I don't know what negative hours at work would look like, but I imagine your boss would like it if you could figure that out, because I think that would mean you'd have to pay them. So maybe you shouldn't work on that too much. But the idea here is that reasonably, you'd talk about the minimum amount of time being 0. So if you want to find less than 4, you'd think in terms of 0 to 4. But the problem with the model as we have it set up is when we're looking at these things, even though they're small and realistically irrelevant values, the values below 0 do still have some probability associated to them with our distribution. It's kind of a weakness of applying a fairly abstract thing to a fairly concrete situation, and it's the sort of thing I'll talk about again in the next example. Now I'll pop back in here and explain what I mean when I get there, but the point is that in reality, if we want to talk about this sort of thing, we'd probably just look at it from 0 to 4 and ignore that bottom side that doesn't actually tell us anything about reality. But for the sake of this, we're still learning how to work with our distribution. We're still learning how to work with our distribution functions. We're going to let that slide, understanding that even so, the probabilities we get down in that tail, there aren't that many of them, but for the sake of this, they do kind of matter. Anyway, back to the video. the standard normal is just a specific representation in terms of z-scores, hence why there are something called standard scores as well. But if we're more comfortable with this method, if we're more comfortable with the calculator-based method, there's never any real need to convert except to just get more practice with that stuff. But generally, either of these two gets us to the same place. And we're going to finish this section here with another example looking at areas between two values, and finally, so we can get one, areas above a value.